Hello, this is Mr. Jones, and I'm going to talk to you today about ratios and rates. A ratio is a comparison of two quantities by division. Ratios can be written different ways. It can be written with the word to, it can be written with a colon, or it can be written as a fraction. Since it is division, for our class, we're going to write our ratios as fractions. Let's take an example here. Let's say a team has 3 wins to 5 losses. We would say that the ratio of wins to losses is 3 to 5. That's wins to losses. Now, it is important to write ratios using the number that comes first for the numerator and the second number as the denominator, because 3 to 5 is different than 5 to 3. Those two fractions are not equivalent. So again, it is important in writing ratios which number comes first. Ratios are commonly used with surveys. Here I have a simple survey in which students responded to a survey saying if they have a job or do not have a job. There are a total of 100 students surveyed. 60 of them do not have a job. 40 of them do have a job. So let's say I want to compare two quantities here. I want to compare students with a job to those without a job. So I would set that up with job over without job. And that would be, with job would be 40, without a job would be 60. Now since this is a fraction, I would like to simplify it. So 40 over 60 simplifies to 2 to 3. So 2 students with jobs to every 3 students without jobs. So we've talked about ratios. Now I want to talk about rate. Rate is a ratio that compares quantities in different units. The key here is the different units. A unit rate is a rate with a denominator of 1. If you've ever been to the grocery store and looked at the price of an item, if you looked close enough, you probably saw the unit cost for that item as well. The unit cost would give you the cost per ounce or the cost per pound. In this case, I have dish detergent, and I have different sizes. And if I wanted to find out what the best size was, I would probably look at the unit cost for each one. So I could set this up as a rate and say that the trial size, which is 6 ounces, I'm going to do the price here. So it's going to be price over volume. And that is my rate right there. And I want to find the unit rate or the unit cost for this trial size. So I'm going to set up the cost. So 0.78 is the price over the 6 ounces. And when I change this to a unit cost, I'm going to divide 0.78 by 6, and I would get 0.13. And that means that the cost of the trial size is 0.13 or 13 cents per fluid ounce. So that's 0.13 per fluid ounce. So what about the rest of them? So let's look at the unit cost for the rest of them, and so we can find the best buy. So for the regular size, it would be $1.20 over 12 ounces, which comes out to 10 cents per fluid ounce. So that is 10 cents per fluid ounce. And let's do the family size. Again, I set up the rate, which is going to be $2.24 over the 28 fluid ounces, and that comes out to 0.08. So the unit cost for the family size is 8 cents per fluid ounce. And let's do the last one, the economy size. The economy size, the price is $3.60. But you get 40 fluid ounces in this one. So even though it costs more, it has more fluid ounces in it. So when I simplify that, this is my rate, I'm going to change it down to a unit cost. I get 9 cents, 0.09 per fluid ounce. So the economy size is 9 cents per fluid ounce. So you can see, even though they are different prices and you get more volume-wise on some of them, you can find out which one is a better deal simply by coming up with the unit cost or the unit rate. So the best buy here would be the family size at 8 cents per fluid ounce. Now that you know what a rate or a unit rate is, you may be asked sometimes to change that rate using different units of measure. This is called converting a rate, or in some cases it's going to be called dimensional analysis. We'll talk more about that later in class. But let's say I want to take this rate here, or actually unit rate, of 10 miles in 1 hour. And I want to change that to feet per minute. So how many feet per minute is in 10 miles 1 hour? So I'm going to convert this to this. So I'm looking for these two numbers here. So I'm going to convert this rate. The first thing I want to do is set up my rate, which is 10 miles in 1 hour. I'm going to multiply this with what I call a conversion factor. Either going to convert the hours to minutes first, or I'll convert the miles to feet first. Let's do miles to feet first. So I want to keep feet in the numerator, and I want to change miles to feet. So I'm going to say 1 mile is the same thing as 5,280 feet. Now I'm going to do the same thing with hours. I want minutes in the denominator, so I'm going to set up my conversion factor. Convert 1 hour is the same thing as 60 minutes. Because 5,280 feet is the same thing as 1 mile, that's basically saying I'm multiplying by 1. It's just like saying 1 hour over 60 minutes is the same thing, so I'm going to be multiplying by 1. So when I multiply across, I'm not really changing the value. All I'm changing is the units of measure. And if I look close enough, I can see if I cancel out. So I have miles, miles cancel out, and hour, hour cancels out, leaving me feet and minutes. And that's exactly what I want, feet per minute. So now when I multiply across, I have 10 times 5,280 times 1. And that would give me 52800, and the only unit of measure left is feet. So that is all over what's in the denominator. So I have 1 times 60. So I have 60, and the only unit of measure left is minutes. Now I'm going to simplify this and change it to a unit rate. So 52,800 feet over 60 minutes simplifies to 880 feet over 1 minute. So 10 miles in 1 hour is the same thing as 880 feet per minute. Now, we're going to spend a lot more time in class going over dimensional analysis or converting a rate, but this is just a short example, and we'll have more practice later on. I hope this helps.